Hi everybody and welcome to Harfang High Level tutorial. We will see how to make a generic genetic algorithm with Harfang. So first you need to import Harfang High Level, rename it HL for simplicity. Then you initialize it, create a window of 1024 by 768 pixels. We will add an FPS camera, which I'll put in the scene at a specific place to see everything when we will put our ground. That's it, and now our game loop to draw and update the scene. And for now, nothing. So what is a generic algorithm? We need to have some gene pool and some test subjects. So we will create a genetic file, so save genetic py. So we need Harfang level 2. We will need numpy. So we will decide to have 50 test subjects. And we'll put it in parameter to change it easily. And we will store our test subjects in an array. So we need to create and initialize our test subject. We'll give it the name of the pool and how many gene count. So gene, it's a number of gene in the genetics. So a gene will be decided by the scene to say what we want to do. So I will explain later. So for now we will create a pool of test subject. And we will create an array. So append for each subject an array A. So we will ask numpy to give us a random array of gene count, and it's between 0 and 1, but we want between -1 and 1, so we multiply by 2, it's between 0 and 2, and -1 to have between -1 and 1. And we will store a score to give how much the test subjects succeed the test, and the best subject will reproduce. So this is a global, and now we need to initialize them in the main. So what we do now, we will import genetic and initialize. So genetic will create an initialize test. We need a name and a gen count. So because it's a generic one, we will call an experiment. So our experiment will be to launch some sphere. So we create a new file. We call sphere launch.py. We need several functions to make it simple. So a simple get name. So return cube launch, sphere launch. Another to define how many genes we have. So in this example, it will be 3. I will explain later. We will get how much the test per subject will be. And we get 5 seconds per subject. Now we can go back here. So the name will be given by the experiment. So we can import sphere launch and rename it experiment. So if we want to make another experiment, we just create a new pi function like the sphere launch. So it's experiment. So get name and experiment. Get gene count. So our genetic pool is initialized. Now we need an environment. So in the sphere launch, we will create and define our first environment. So initialize experiment environment. So we'll need Harfang High Level in here too. Import Harfang High Level, limit HL. So we want a physics ground. So it will be a physics box on 0, 0, 0. And it will be a big size because we just want a ground. So a 50, a small width, and 52. We need two spheres, static sphere, to just show for us where we launch and where we want to stop. So it will be just a simple add sphere M for matrix, and I want to give a matrix translation at 4, and we give a vector 3 for our translation matrix, so it will be 10. This is the start sphere, and a radius of 1, and a second one will be on the ground, 2 meters, 3 meters on height, and 1 sphere, and we need a physics sphere which will be used by all the test subjects one by one. So the physics sphere, it's HL add physics sphere, and we will start here. So my mistake, this is the start and this is the end. So it's 10 meters away on x-axis on the ground, near on the ground. So we don't need that. So this is the matrix, it's the same start as here. So it will be a radius of 1 and a mass of 1 kilogram. We need to save the sphere, so global sphere, and sphere is initialized here. So we have our environment. Let's make the experiment initialize too, and let's see if everything is at the good place. So we see we have our starting sphere, which just fall down on the ground. It doesn't fall through the ground because it's a physics. This is the start and the end. So now why we have 3 gene? Because we want to make a 3D impulse from here in physics, so, and to have the ball go here. But we don't want to find it by ourselves. This is why we have the genetic algorithm. So we will make a pool of 50 test subjects. The 50 test subjects will be randomized value with 3 value to just launch everywhere. And we will see after how to find the score. Now we have our experiment ready, and we have our genetic algorithm with test ready. Now we need to prepare one test for one generation. So what we need is to say where are we on the current generation. We get the duration test from the experiment. This is the current timer for each test, so it's duration test. The current score for us, and the best score. For now it's very small because we don't have anything. So we will get our gen pool from the genetics. and say, okay, I want from the test subject, from the current tested one, so it's a 0, it's the first one, and we want the array A. Now we need to ask the experiment to initialize the experiment in the environment for this particular test subject. So we need to make this function. So what we want for each subject is to put the sphere at the right place. So we'll give gval physics not reset word, so it's to reset the sphere at the first position. So we just grab the matrix and say, okay, go back to the position, and now our physics simulation and will get from the array gene the impulse. So after we evaluate on this impulse. So node add impulse. On the sphere, and we will make a 3D impulse from this array gene. So this is why we need 3 genes. So it's for X, Y, Z. Array gene, so Y and Z. And because it's a small array between Y minus 1 and 1, we will give much force, so I just multiply by 40 in this experiment. And now, because we are here in our experiment, we need to ask how many, what is the score for this one, and the score is evaluated by the distance, the current distance to the final sphere. So evaluate score, which return the distance between the final sphere. So it was 10, 1, 0, and the position of the sphere, the current sphere get word to have the word matrix, which will give get t the current vector. And now we have the distance, get t, get transform, get word, and we multiply by -1 because we don't want a max score the further away, we want the shortest, so we want close to 0. So if it's very far, it's not 50 meters, for example, it will be a score of -50, so small one. So we have everything in our experiment. Now let's make the experiment working. So in our game loop, we'll get the dt, which will be very used here. So we ask get dt sec. So if the test timer is running, so up to 0, we just decrease the counter by dt sec and ask the current score. So experiment get evaluate score, and that's it. But if the test timer is currently under 0, this test subject is has finished the experiment, and now we get the final score and move on to the next one. So genetic test subject. So the current evaluated one, and we update his score, which will be used for the next generation. After, if we want, we have to check if we need a new generation. So what is if the current index is up the size of the generation. So up, genetic test subject. Now, if we test all the subject, we need to make a new generation. So, for example, for now, we will just get the best score from another function. So, genetic make new generation from this experiment. This is in case we have multiple experiments at the same time. So, and we reset everything. So, genetic current generation, we will save it. It will be easier for us later. So, current generation, we want to keep track on it. So, current generation is 0. And we reset the test subject to 0, 2. And now we reset everything. We reset the timer anyway and go back to our next subject. Score, we reset the score. And we get the next subject for this test subject. And we initialize the environment for this one. And that's it. Now we need to make this function to make the new generation. So this is evaluating, so we need a new function. This is the most important one. Make new generation for this name. So we will make some modification of the test subject. So we need, for this generation, to ask a number of subjects which will be the parents for the next one. So how many subjects we will take? Best subject. We say we can take 10 of them. So our current array, we need to sort by score. So there is already function, so test subject, key lambda, to say on what we will sort it, so by score. So by default score, it will be from the least score by the highest, but we need to invert the array. So it's this function, which will give the sorted by the first will be the best score. Now we reset the test subject because we will create a new generation. So for a new generation, we'll create a new array of the pool of genes. From the best, and just in case we take the current shape, because if we want a genetic algorithm more sophisticated, which can change the size of the pool, the size of the gene pool, we will fill by default with 0.5, just in case. And now the most important. So for each gene, so we for this example, it will go for the 3 gene we have. We will take a random parent from the best one. So from 0 to NB best subject, so 0 and 10. We will get a random number between 0 and 1. So it's just random. And now the fun begins. So we want, for example, a mutation completely random in the middle. So if random, it's but very few completely mutation. So an array of j, and we add a random value -5 and multiply 0.5. So it's just like from the already here array, so it's 0.5, we'll just add a little random, so it's a mutation from nowhere. Now next, we want a random, but from the parent we selected. So random inferior to 0.02, for example. So array j equals sorted subject id parent. So in its array for this particular gene, and we add a random, the same 5. So it's a small random from the parent. Now we can just select invert some gene just randomly too. So 0.4 for example. So we select a value random. We will from the parent, so sorted subject, we'll take a new random value, random2, and we say int random. It will be genetic pool, a very lot of random. So select a random gene in the shape of the gene pool. So in the parent, we ask to take the array, and we'll give a new random. So for example, the X can be changed to the Y in this example. And now we can have a much more random, so it's a mix between the two parents. And from the two parents, so we get the second parent, parent 2. So it's the same as here. And we will get another random mix, so between 0 and 1. So random. So our new gene will be a mix, so 1 minus random mixed of the first parent ID, this one, plus the second one, parent 2. And for the rest of the random, we can just say copy from the parent. I will take directly the gene. Now we have all our new gene, and we can add this array as a new test object. Append and the same a array, and the score by default is 0. And we can return the best score to keep track. So the first one is the best score and score. And we have our new generation. So our new generation is here, the best score is here. Now let's add some UI to see if everything is okay. So draw text 2D. So it's a formatted function from Python. So the ID current agent tested. So it's a current index tested by how much we have, genetic and B test subject. We'll put it in 5 pixels on X and 130 on Y. We will tell also, we'll check how much we have generation, so F, so current generation, genetic, so current generation, we'll put in 5, 2, and 100. Now we can add some other value like what is the current score, if we see if everything is working as we wish. So it will be a score, but it's a big one, so we simplify by just showing 2 digits, 5 and 65 pixels. We do the same with the best score. And that's it. Now let's see if everything is working. So we see I didn't put it at the right place, so the ball is falling. So I will just move it a bit to see our generation. So 5 seconds, it's for now very big, so I just make it just 1 second to see better if it goes to the next generation. 1, 1. So we see at first it will randomly go send an impulse anywhere, and if we wait a bit, I will show in the video. So 50 generation. So now I want to test the next generation, so we will put less test subject, or just 2 and 1 best. So 1, 2, and crash. So random is not defined, and it's better to import random. I use it everywhere. So restart. So we have our generation, so 2 test subject and generation go wild, and we see the best score is pretty better, just with 2 tests. So it's like the meter from this one. So the sphere is 1 meter in radius, so it's a big sphere. And what we see is the score go lower and lower, but can just be a bit higher too, because it's random. So the next generation is not very specific. And for now, I didn't find anything to go here, but there is only 2 agents. So let's put back a bigger one. And now we wait. And that's it. You know how to make a genetic algorithm. We can do another environment, another experiment by just changing the test subject. Maybe I will do another video to make a new test experiment. Tell me in the comment if you want. See you soon with new tutorial.